Hey, I wanted to provide a little guidance with the Ohm's law of power and energy practice problems. Number one, automobile headlight with a resistance of 30 ohms is placed across a 12-volt battery. So let's see what we have. We have R and we have V. So we have V, we have R, and A, B, and C. What is A asking for? What is the current through the circuit? So it wants to know I. So it looks like this is an Ohm's law problem. V equals IR. So I would use V equals IR to figure that out. B, what charge does it accumulate after some amount of time, after 5 minutes? So what that is asking about is it wants to know a charge. It wants to know Q at some amount of time. So you'll have to go back to the current formula. So I is a charge per time. So if you get the current from the Ohm's law from the first part, then you should be able to figure out a Q given an amount of time. Make sure you use seconds. And then once you know Q, you can turn Q into a number of electrons, always with the Q equals NE equation. E, again, is the charge of an electron, negative 1.6 times 10 to the negative 19th coulombs. What's 2 about? Let's see. We got the motor. Oh, this one was done in the Ed puzzle. So let's take a look. It says, right, so you have V and I. Let's take a look. V, I. And it wants to know power. So, right, so we use PIV. Power equals current times voltage. And how much energy is delivered. So energy is power times time. Number 3. 3, current through a light bulb across the terminals. So an outlet is that. Wants to know the power. So this looks like a straightforward PIV equals IV. You've got the voltage and the current. In 4, car battery, you've got current, you've got voltage. It wants power, same thing. 5, current through watt. All right, so it's looking for I. In this one, it's looking for I, and it's giving you power. And what else? Giving you voltage. All right, so PIV going a little backwards, looking for current. And 6, current through starter motor. So we've got current, we've got voltage, and it wants energy in an amount of time. Let's take a closer look at number 6. So number 6, so we've got I, current. We've got battery 12 volts, so we know voltage, potential difference, and what electric energy, and they're giving you an amount of time. So energy, so we did a similar one in the, or did we do this one? Knucklehead. We did this one in the Ed puzzle. So energy is power times time, and since power is IV, you can solve that and plug it in and figure out the energy. I forgot we also did number 7. Let's take a look at number 7. Again, 7, we had I and V. Lamp draws that much current, that much voltage source. It wants resistance. So that looks like, again, Ohm's law. V equals IR. And what is power consumed? So power looks like you can do a bunch of things, but I would just go PIV. 8. Hey, thanks for pouring cereal, John, while I'm going over problems. That's great. Number 8, we've got 75 watts, and we got voltage. So we got power and volts. We got power and volts. What is the current and what is the resistance? So current and resistance. So if we know power and voltage and we want to know I, it looks like we would use the PIV power formula. If you want to know resistance, you could use P is I squared R. You could use P is V squared over R. You could use V equals IR. Take your pick. We've got number 9. Number 9, we've got 15 ohm heater. So that is a resistance. And it's operating a voltage. And what is the current through the heater? So I. So let's say V equals IR, it looks like. V equals IR, Ohm's law. Then how much energy in an amount of time? So energy in an amount of time. Energy being power times time. Looks like you could find power again, IV times time. You got it. Number 10, last one. Number 10, 30 ohm resistor, 60 volt battery. So resistance, voltage, and it would like to know current I. So it looks again, V equals IR, looks like Ohm's law, and how much energy in amount of time. Energy, again, power times time. If you're given time, you could do an IVT. Power is IV. IV times T should give you energy. Hope that helps.